today our big goal is the second objective, which is going to be modeling a parabola by writing an equation in vertex form. And we'll do that using a graph as well as word problems. Now, you are not having a quiz on section 5.3, but and I need to put it up there. This Thursday, you'll be having a performance task, which is kind of like a partner challenge, but they're all application problems, like word problems. You'll get to work with a partner. However, you won't get to use your notes. So we'll still have like a review day, almost like a quiz, but you'll get to work with a partner, and it will be all word problems in terms of applying our parabolas and quadratic functions. So that's why today's notes are going to pay extra close attention on our word problems. Okay. All right, so writing the equation of a parabola, we can use the vertex to write the equation of a parabola when given the graph. And the easiest way to do this is, of course, in vertex form. So let me just write that a little bigger. If you haven't memorized this form yet, you want to, for obvious reasons. And the steps to solve this are typed out for you, so you don't have to jot them down as we're solving. The first thing that you want to do is identify the vertex, obviously, from the picture. That is h comma k, so you'll be able to substitute in a number for h and a number in for k. Now, the only letter you'll be missing then is what a is. Is there a stretch or is there a shrink? Now, you can check and see if it goes up 1 over 1, up 3 over 1. We know a should be 1. Okay, but we're also going to verify by picking one of the other points they gave us, and we'll plug those values in for x and y, and we'll actually solve for a to find out what a is, to prove it. All right, so in this first problem, we see that our vertex is 3, 4, which means that h is 3 and k is 4. That gives us 2 of the values. So I'm going to take and plug those in to my vertex form. And it does not look like it's going down 1 over 1 because it doesn't actually touch the box. So we are going to have to solve for a. So in the second thing we're going to do, or excuse me, the third, so we're going to plug in the values of x and y for another point that they've given me. So this is not a vertex, this is just a point. So this is an x value and this is a y value. We'll plug those in. So we'll have -4 equals a times 5 minus 3 quantity squared plus 4. We want to simplify first, and then we'll solve for a. And when we're simplifying, we do want to use our order of operations, so think about PEMDAS. So we're going to do our parentheses first, then our exponents. 5 minus 3 is 2. 2 squared is 4. And whenever I do this, I usually write 4a instead of a4 because that's more normal looking in terms of algebra. And then we just solve using inverse operations. So we would subtract 4, get -8, divide by 4. Look at a is -2. Last thing we need to do then is plug that actually back in to the equation to get the final formula, which would be y equals -2 times the quantity x minus 3 squared plus 4. And that's our final answer. Now some students will say like, oh, I noticed it goes down 2 and over 1, which a lot of times that is a good way to check it. I would always verify. And sometimes they're going to come out to be like -3/4, -1/6, something that's not as easy to notice by the graph, but you can use it as kind of a check. Okay, let's do one more, example B. Oops. So again, identify your vertex, which you can just label it. This is my vertex, so that's my h comma k. Write it on the picture. So we'll have y equals a times x minus h squared plus k. So substitute those values in for h and k. So this is x minus a -1, which would be a +1, plus 0. Again. So first step is to plug in the vertex. Second step is to plug in the point. So now we'll plug in x and y. Could you do those at the same time? Yes. It just makes it easier for a lot of you to do it separately. So this will be 2 equals a times negative 2 plus 1 squared. And I'm just going to drop off the plus 0 actually, because plus 0 doesn't do anything. Make sure you're careful with your algebra here. Negative 2 plus 1 is a negative 1. And negative 1 squared, negative 1 times negative 1 will get me a positive 1. So a is just 2. Take that and plug it back in to get our final equation. And if you want to put the plus 0, you can, but you are not required to. All right. Now the rest of them are word problems. You do want to sketch a picture to help you with the word problems to understand what the graph looks like. So you'll look at the format. If it's a positive a value, we know that our parabola would be facing upward. If we see a negative a value, we know that it'll be facing downward. Because all of these problems are going to be in vertex form, we're going to know the vertex right away, h and k. Okay, so that's one thing we want to identify, but let's read through it and see if we can come up with a picture. So a long strip of colored paper is attached as a party decoration at the top corners of a wall of a rectangular room. So in here, imagine it hanging up there and like drooping down like a streamer and hanging up in that corner. The strip approximates a parabola with this equation. The bottom left corner of the wall is the origin. So if you think about this going down to the bottom of the floor, that's the origin. X and Y are measured in feet. How far apart are the corners? So how far apart or how long is this wall? And then how high are the corners? So let's go ahead and draw a picture. And if you want, you could draw a rectangle since it says a rectangular room, if that helps you. Mine's really just not straight at all. So we have, again, you can see that this is a positive value, which is telling me that my parabola is going to be facing this way. Okay, it's just facing upward. But we know it's starting at this corner, it's going down, and it's coming back up. Probably could have drawn that a little bit better so it looks symmetric, but it's just a sketch. All right, they also tell us that the bottom left-hand corner of the wall is the origin. So down here, this is like our y-axis, and this is our x-axis, and this is the origin, 0, 0. All right, so the first thing you want to do after drawing the picture our second thing is going to be to identify the vertex, because this is in vertex form. So what is my vertex? Jade? 25. Good. Remember, the x value is always the opposite sign of what you see, so since it's a negative 20 or minus 25, we'll take a positive. And that's because the formula is x minus h squared plus k. All right, you also want to then plot the vertex in your picture. We also want to then draw in the axis of symmetry. So the axis of symmetry has to go through the vertex, and it's a vertical line. Now the reason that the axis of symmetry is going to be so useful is because we know there's symmetry across it. So things have to be equal distances from one side of the vertex to the other. And then sometimes it's useful to find a couple things. If this is 25, 10, so you go over 25 and you go up to 10, right here, this point, even though it's not an actual point on the parabola, just a point on the axis of symmetry, this would be, and you could just label it 25 on the x-axis. That's going to be useful to you. Because if this, let's not put a point there, let's just put a little marking. If this is 25 and this is 0, what does this have to be? 50. Because we know that anywhere on the parabola they have to be symmetric. So anytime you have the vertex, you might want to come down to the x-axis and label that this has to be 25 units from 0, which then makes that 50. Now the next thing we probably want to find, because they do want us to know how far apart are the corners, which actually we just already know that. How far apart are the corners? They're 50 feet apart. So the first question we'll have answered. Second question asks us how high are the corners. So we already found out that they are 50 feet apart. This wasn't feet, right? Now we're looking at how high up they are. So we need to find one of these 2 points. What's this point called in terms of the parabola and where it's intersecting? Hannah? That's our y-intercept. Perfect. Now in the y-intercept, when it was in standard form, we just looked at the c value, 0, c. When it was in standard form, x squared plus bx plus c, so 0, c. In vertex form, it's not as easy to identify the y-intercept. So to find the y-intercept, we notice that the x value has to be 0, right? So this is going to be 0, something. So the fourth thing you'll want to do, and you don't always have to do this for every problem, but in this case we do, we want to find the y-intercept. And to find the y-intercept, we're going to plug in 0 for x, and then solve out for y. And we will probably want to use our calculator for this one, because we're going to get some big numbers. So plugging into our original equation, we'll get y equals 0.008 times 0 minus 25 squared plus 10. Because otherwise we'll have to do 625 times 0.08. And you can type that whole thing in. You don't have to do the piece by piece if you're using the calculator. Obviously if the numbers were smaller we would do it by hand, but so 0.008 times 0 minus 25, close parentheses, square it, and plus 10. We should get 15. Okay, which means that this is 0, 15. This point would have to be 50, 15. Not that necessarily we need that, but just kind of adding it to our picture, because we know that these 2 points have to be symmetric about the axis of symmetry. So how high are the corners? They are 15 feet tall. Okay, now usually when I do these on the board, you're like, oh, that makes sense. I get it. But then whenever I throw you a problem on your own, you'll struggle. So you do want to kind of remind yourself to do all of these steps. Use your vertex and your y-intercept, and you do want to draw the picture to help you understand and interpret. The performance task, the problems will be like this. There's 4 of them. And you'll get to work with a partner, but you'll have to be able to interpret a different type of scenario each time. All right, let's look at one more. So this one says a suspension cable of a bridge forms a curve that resembles a parabola. The curve can be modeled by the following equation. X and y are measured in feet. The origin of the function's graph is at the base of one of the 2 towers that supports the cable. So start by drawing a diagram. So again, I usually just draw an x and a y axis. And so we're going to need 2 towers, and then between the 2 towers, the suspension cable is going to come down and attach to the bridge at some point and then go back up to kind of take the pressure off of the middle parts of the bridge. So I'm just going to draw one of my towers. I'm going to draw them really skinny. It's being like right there, because it says the origin is the function's graph is at the base of one of the 2 towers. So I'll just let it be the first one. And then somewhere over here I'll draw the other tower. And then it probably should have, since you might not realize that, but a suspension cable bridge is going to come down and touch and then come back up. So it's actually going to go all the way down. Our streamer question, it just went and drooped down because it was a decoration. We weren't putting it all the way to the ground. But the whole point of a suspension bridge is that the cable actually takes tension away from the middle of the bridge by attaching it to those poles. So when we draw this, The parabola is actually going to come all the way down and then go back up. Just do your best. So we've drawn our diagram. Now we want to identify the vertex and the y-intercept. So what would the vertex of this be? Looking at our equation. What would the vertex be? Ashley? 2,130. Good. H, comma, K, which is the K is a plus 0. This would also indicate to you that the vertex indeed does touch the bridge. So I guess they didn't have to tell you that, because whenever you find the vertex, that will make sense. Go and label it in the picture too, because this is going to help you find something else out. You also might want to sketch in your axis of symmetry. And then usually I say just find the y-intercept right away too, and then we can figure out what answer goes to what question. So to find the y-intercept, remember that means to plug in 0 for x. So in our equation up here, again we'll utilize a calculator since we have such small decimals here. And let's just round to the nearest. It doesn't tell me, so I'll just do the nearest hundredth. So 649.68. All right, so let's go put that into our picture. The y-intercept would be occurring here. So that would be 0, comma, 649.98, roughly 650. All right, so now let's answer the questions. How far apart are the towers? So how far apart are the towers would be looking for this distance. What would that distance have to be? Clayton? Double the vertex, right? So we'll get 4,260. So if this is 2,130 feet away, the other tower has to be 2,130 feet away. So you can either double it or add it back to itself. So this point here would be 4,260, 0. This is 0, 0. I probably should have labeled that. And this would be feet apart. How high are they? So how tall are each of the towers? You don't have to do any work, it's just in the picture already. Abby? 649. Good. 649. Oh, it should be 6.8. Why did I put 9.8? Because I put 9.8 up here. Whoops. Very good. Technically, if we wanted to, we could also find this point. We don't have to, but this would be 4,260, 649.68 in case we wanted it. All right, now the next problem is a little extension. It says, suppose the towers are, so same type of scenario, same equation. Oh no, we're going to write our own equation. Suppose we have two towers that are 4,000 feet apart and 600 feet high. Write a function that could model this curve of the suspension cable. So let's start with the picture again. Our x-axis and our y-axis. We'll have our two towers. And drawing them further apart might make it easier for you to see stuff in the picture. But this time they're not giving us the vertex, they are rather giving us some information about it. So suppose the towers are 4,000 feet apart. So the two towers are 4,000 feet apart. Which would make this tower, if this is the origin, 0, 0, that would make this have a point of 4,000, 0. Suppose the towers are also 600 feet high. So 600 feet would be over here. So this point up here where they intersect the cable and the tower would be 0, 600. This point would be 4,000, 600. Now in order to do, they want us to write this, they should tell us in vertex form. We need to identify what the vertex is. What would the vertex be? What would the vertex be? Abby? Good, you have to cut 4,000 in half. So this is going to ask us to kind of reapply what we did on the front. When we were given a graph, work backwards to write the equation in vertex form. So let's start with a times the quantity x minus h squared plus k. We know that the vertex is 2,000, 0. So that means that h is 2,000 and k is 0. That's the coordinates of the vertex. So we'll plug those in. How do we find A again? Remember what we do to find out what the A value is, the stretch or the shrink. To the front. Sam? Good. We're going to plug in one of the points. That's on the parabola. I would pick the one that has a 0 in it just because it makes your calculations a little bit easier, but you could also use the other. You don't want to plug in the vertex. We've already plugged in the vertex. So you want to pick one of the other points. So I would probably choose the 0, 600. So this is my x, and this is my y. So that would be 600 equals A times 0 minus 2,000 squared, technically plus 0. And then we'll solve out for A. And we are going to get a very small number, just like the other one was 0.001432 or whatever. So we'll square the numbers first, and we'll get 4 million. And that will be a positive because negative squared becomes a positive, and then we'll divide. And I'm guessing we'll have to round this at some point. I don't think it's going to come out to be nice and perfect, but let's see. Ooh, gives us a scientific notation. Okay, you want to actually expand this out because you don't want to put that in your equation. So remember, if it's 1.5e to the negative fourth, that means that you're moving the decimal 4 places to the left. So we're going to actually take this number and move the decimal 4 places to the left. Now to do that, we'll have to put some zeros over here. So over 1, 2, 3, 4. So this would be 0.00015 is my A value. And then we'll take that, plug it back in for A to get our final equation. Y equals 0.00015 times the quantity x minus 2,000 squared. Alright, see if you guys can answer the 2 closure questions where you're asked to just identify the vertex, which is right in front of your eyes. Also identify the y-intercept, which remember the y-intercept occurs when x is 0, 0 comma something. So see if you can find those values while I pass out the homework. And then when you get the homework, I do want you to, and I'll remind you again, we're going to add a question on the back Number 13 is a word problem, and I'm gonna ask you to add an additional question to it. All right, so you'll see some questions like that. I did want to also mention you can use your graphing calculator also to find the y-intercept. So if you wanted to, I think it takes more time, but you could type in the function, and then you can go to the table and look when x is 0, what is y. So it will calculate it for you. So if you wanted to take the time to type the equation in your y equals, and then look for, again, y-intercept is when x is 0, it will tell you in the table. This is just one that I had typed in from before. So on the back of your homework, everyone turn to the back, number 13, which is the only word problem you have for homework. I want you to add in, it asks you several questions. I want you to add in how long is the ball in the air before it lands? How long is the ball in the air before it lands? And you'll notice for number 13 that the equation they give you is not in vertex form, it's in standard form. So you might have to use some prior knowledge of how we find the vertex from section 5.2.